Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome to Hasim Electronics. Friends, this series of Inverter IGBT Welding Machine functional description and repair procedure troubleshooting. In first step, I discussed this portion, rectifier circuit, input rectifier. It takes 220 volts, rectifies and gives us DC voltage. If you want to watch this video, you can go to the link in the description. In next video, I discussed output rectifier high frequency transformer. In next video, I discussed high frequency transformer and rectifier unit. This takes high current drive and provides us voltage, and this board rectifies, and we take output voltage for the electrodes for the welding point. This video is already available in my channel. You can visit and you can watch this portion. After that, I discussed IGBT. Here is IGBT, insulated gate bijunction transistors, IGBTs, and here is gate driver network. It takes 300 volt, 330 volt, and switches in the form of voltage pulses. These pulses drive the output high frequency transformer. This video is already uploaded, and in this video today we will discuss this low voltage section, low voltage power supply section. And this board have a problem. This IC is damaged. It have blasted and it is damaged very badly. The number is not visible. How we can find for number for any unknown IC, and how we can troubleshoot, how we can repair this portion, today we will discuss in detail. This one is input terminal. It takes DC voltage from this section, from this board. So AC voltage are applied here, and DC voltage, DC output of this board is reached here. The red wire, that is positive, and this wire is ground. Positive and ground from the capacitor reach here. If you look at this point, this positive voltage will come at this point. Here is a jumper. Where is that? It is here. Normally there is a plastic jumper connected to make jumper in these 2 points, but here this jumper is permanently soldered. Why? Because the removable jumper is most of the time makes problem in the high voltage. When it is in digital circuit, it works okay, but for high voltage it makes problem for 300 volt plus. And because it is movable machine, so this jumper is good that it is soldered. So this voltage will reach from this point to this point when the jumper is connected, and from inside, from the inner side, from this point, these voltage are reaching at the primary of this transformer, high frequency transformer. This one is high frequency transformer, pin number 1. And if you look at this point, the footprint of this IC, pin number 5, 6, 7, 8, 5, 6, 7, 8, these are connected to drive pin number 2 of this transformer. Pin number 1 takes positive voltage, and this one gives drive pulses. So pin number 1 of this IC is ground pin. So it takes ground from the main input voltage from this point. Where is that point? It is connected here. So we will receive negative voltage, negative terminal of the capacitor at IC pin number 1, and positive voltage to the transformer pin number 1, primary winding pin number 1. Now we have issue that this IC is damaged. We have no information about this IC. So let's check this circuit. After that we will discuss how we can make solution for this IC. Same time, these positive voltage which are reached here will reach at this component. What is that? It is a resistor. If we look here, positive voltage will come to jumper, after that at this resistor. This resistor is 30k resistor. This one. This 30 kilo ohm resistor is connected to VCC capacitor here. Here is VCC capacitor, this point. Positive, and this end is connected to ground. So this capacitor will charge and this voltage will reach to pin number 3 of this IC. Pin number 3 of this IC. So this IC, when it will take VCC and it have ground at pin number 1, pin number 2 have a resistor and it is connected here, pin number 2. So here is pin number 2, it is connected to this pin, and the resistor second end side, this end is connected to ground. So we can say this resistor, it is current limiting resistor, it is connected to pin number 2. The same ground line is connected here. This is VCC winding of the transformer, auxiliary winding. This pin is grounded, and the second, which is the output, it is connected at this point, and it is here a diode. Anode of the diode is connected to winding side, and second end is connected to this resistor. So this resistor in series, and it is connected at the same point where is the main resistor, 300k resistor. This one is connected. So VCC voltage will start from here, from the diode, from this resistor, and it will reach to the capacitor. This optocoupler, here is optocoupler. Optocoupler, one pin is connected to ground, this pin, and the second side, this pin is going to pin number 4 of this IC. So pin number 4, it have a capacitor, 102 code capacitor, picofarad capacitor. The second end of this capacitor is also grounded, and this point where the main DC voltage are reaching, we have one resistor here, this resistor. This resistor is connected to another component. What is that? This is capacitor here, and this capacitor is connected to this point here. It is a diode, RCD. So resistor, capacitor and diode, these three components are working as a snubber circuit, as a protection circuit. If we look at, it is at drain pin. This point is connected at the drain side. So in the off period, it will demagnetize the coil and it will remove the excessive voltage stress from the IC. Transformer secondary winding, feedback winding is connected here, FR104 diode, resistor and capacitor. 68k resistor is connected in parallel to this capacitor. So 300k and 68k. So it is pull down resistor for VCC to protect it from false switching. So the voltage will be smooth. Pin number 1 is grounded, pin number 2 have 1 ohm resistor. When this IC will damage, this 1 ohm resistor will be damaged. It should be open. In the secondary we have two diodes. We have two diodes here. The cathode side is connected to this capacitor, positive terminal, and the negative is connected to common, and the same positive terminal is connected to these two resistors, and resistor second end is connected to this 7805 IC, and this resistor is connected to 7915 IC, and we will take output, one output from this point, second output from this point. So we have three type of power supplies. The one that is the main supply, main capacitor is connected here at this point. At this point here is a zener Z2. In series of zener there is a resistor, current limiting resistor, and it is connected to optocoupler pin number 1. Pin number 2 of this optocoupler is connected directly to the ground. So this IC just need enable pulse. It does not need a regulation pulses. So that means how we can determine this IC, what is the number of this IC. Some of the boards, some of the manufacturers, some of the designers, if they have good designing technique, they will share the part number on the board. If there is no number mentioned on the board, then you have to search for the footprint. You have to search for different ICs when the footprint will match. Now we have data 5, 6, 7, 8. Pin number 5, 6, 7, 8 are connected to drain. Pin number 1 is source pin, that is grounded. Pin number 4 is feedback. Pin number 3 is VCC. Pin number 2 is I-sense, current sense resistor. So that means we have to locate a IC which should have the same pin out. That is called pin for pin combination. Then you will find from the internet, from the different catalogs, but unluckily these ICs are from China. So these Chinese ICs have no data. Most of the time you will not find data. If you will find data, you will not find an equivalent, because every designer makes his design unique. So according to my experience, it is 6832 IC. So let's remove this IC and we will check this footprint, maybe if there is something visible. So it is 6834. Its number is SD6834. So it is closely to SD6832. So I have to locate this IC. If I can find, then we can replace it. Now the first solution, how you can overcome this issue. If you don't find this IC, should we leave this board? Because it is in portions. If this portion will not work, our other system will not work. We have many solutions. We have to search for the solution. First of all, see the diagram and then we will discuss what is the possible solution. Positive voltage reached here at the VCC pin through this resistor. It is startup resistor. This IC have ground. This IC have current sense resistor. So this IC should start work. It must start work. If you have voltage at VCC pin number 3, pin number 1 and 2 connected to ground through this resistor, that means it should work. It should give up pulses. When it will start pulses, it will start from this way. On each off period, this number circuit will work and it will protect this IC and it will reduce the voltage stress and it will demagnetize this winding in off period to reduce the current for the next cycle. Secondary rectified voltage 25 volt 7805 7815. So 5 volt, 15 volt, 25 volt. When the voltage will reach at a specified level 25 volt, this zener resistor, they will come in series. So it will take activation voltage. So it will activate and it will give enable pulse. So this IC will smooth its switching level to produce the power supply. Now, if we cannot find IC, what we will do? If you have any switch, any power supply in any section, and you cannot find any technical manual, anything about that circuit, what we will do? We have to, first of all, we have to check the output of this SMPS. How we can check? Now this time the IC, we don't have IC. This transformer will not work. So to check this voltage, I have solution. So we can monitor and we can determine the operating voltage of next circuit. Locate the capacitor, negative and positive. So connect one lead to negative. We will inject voltage and we will monitor the response of the circuit. Now locate the optocoupler, output side, connect one wire to the output pin which is connected to the feedback pin of this IC, so that is here, and the second wire connect to the second pin which is connected to ground. I connected two wires, one wire to the ground of the capacitor, second wire to the positive of the capacitor, one wire to the optocoupler which is going to IC feedback pin. So it is feedback pin, it is connected here, and this line is connected to ground, pin number 1. Any IC, any SMPS you can determine like this. So now set multimeter to ohm to measure ohms. Connect black lead of the multimeter to the point, ground point, and the positive lead to the second pin of the optocoupler. So we connected both leads here. I have external power supply. Connect the ground side of the power supply to ground of the capacitor. Never connect reverse. Positive side. So it is positive side is here, positive side inside, and this side is ground. This side is ground. So now I will increase the voltage slowly. I am starting from 5 volt, 6, 7, 9, 10, 15, 20, and we have to see the multimeter dial. Now it is in ohm mode, not in voltage mode. I connected at these 2 points, and we have to see the multimeter reading. When the multimeter reading, we can see before this it was open. Now it started switching. When the multimeter will reach at approximately 500 ohms, 600 ohms, that means this time this feedback circuit is enabled. I applied voltage here. These voltage reached to this Zener diode and input of this optocoupler, and in the output of optocoupler the internal resistance decreased. So we can say this time when the power supply will start switching and the voltage are reached at required level, that time this optocoupler, this feedback will give feedback that the required voltage are received. So We injected an external signal. We injected this external signal to the capacitor so that this feedback is reached here. Now we got the voltage level about 600 ohms, 700 ohms. Now set multimeter to DC input voltage 1 volt. And voltage across the zener is 24 volts. So check the voltage at input terminal, that is 25.48 volt. So we can say the output of this circuit is 25 volt. When the output is 25 volt, we can check now the output of these 7815. We can check the output of 7815. It is 14.89 volt. That means this IC is good. Check the output of, oh, this IC is not good. It is 6.8 volt. This IC must have 5 volt. So when it is giving more voltage, that means there is problem. There is something wrong. So we have to replace this regulator because it is giving more voltage. In any case, it should not give voltage more than 5 volts. So first we have to replace this regulator. I have this 7805 regulator because the original regulator is giving more output. So we have to verify either it is problem from this regulator or somewhere else. Then we will look for the IC. So I removed this one and I will use this one. It is L7805 and it is KA7805. So I will replace this regulator. If you have no good practice in electronics, never try to repair at yourself because it need a very special care for in electronics. Now I will check power again. I turn on the power supply. So it is 25.4 volts, the same voltage. Now we have to check the output voltage. So it is 15 volts. It is 5 volt. That's nice. So this regulator is bad. This regulator bad. Might be this was the problem. This IC bad and it give a back load on this SMPS. Might be this was the basic reason for damaging this IC. Because always there is a reason for any damage, any disaster. So I hope so this IC was bad. It gives some wrong output to next circuit. Now how to check the output of this module. Now we applied voltage here to this circuit and this circuit, it should work. It is SG3525 circuit. This module, it should give output to these 2 points. So we have to check the output frequency at these 2 terminals. Set multimeter to measure frequency. Now this circuit is oscillating at this frequency, and we are taking the drive pulse at IGBT. I did not apply 220 volt. I applied just only this supply to the main capacitor, and main capacitor, after that we regulated voltage, and these regulated voltage are applied here. Why we have three power supplies: 24 volt power supply, 25 volt power supply, that is for this relay. This relay is 24 volts. Its coil is 24 volts. So let's connect this coil as well. We can listen the sound when I connect power. Now that means this circuit is working. We located the fault. This IC is bad, regulator is bad, this SMPS is bad. We have to make a solution. How we can solve this issue? First of all, I have to search for the IC. If I can find this IC, that is nice. If I cannot find this IC, what we can do? You can find any converter module, 24 volts. These are easily available in satellite receivers, old one. Every satellite receiver, it have 29 volt, 28 volt, 22 volt. If it is 22 volt, that's also working. That's nice. Why? Because this 15 volt, that means here is a 15 volt regulator. So above 18, 17, 18 volt, we can use any power supply. Just for example, I have this 15 volt output in this board. I have 3.4 volt, 20 volt, 15 volt. So I can use this ground pin and these central two pins. I can remove this connector and these two pins. Positive wire to this point, ground wire to this point, and I will apply. I can connect this DC voltage, this pin to this line directly from here, and this board will work. We can place it in the welding machine in anywhere. So these two wires will be connected here. So this circuit will start functioning, and we will bypass this circuit. If we cannot find IC, this one, so it is very easy solution. Otherwise you have to locate the IC and you have to check if you can find, if you are successful to find it. There was a question from one of my viewers, how we can find the output, how we can check the output of any SMPS without oscilloscope. So without oscilloscope, you can check if you have multimeter, the Hertz function, set multimeter to Hertz and connect to the output points. So you will find the frequency. If there is no frequency, if no frequency option in the multimeter, set multimeter to AC. Now connect the both pins here and you will find some AC voltage. It is 1.3 volt. Why? Because it is high frequency square wave and it is now driving a transformer. So the circuit is working. It is an option. In AC mode, if you cannot find voltage here at these 2 points, that means our SMPS controller is not working. Friends, I hope so this video is informative for you. If it is informative, thanks for watching, and if you have some question, some suggestion, let me know in the comment box. If you find some error, some mistake, please make a correction in the comment box. I will thankful for your positive attitude, and I will thankful for your feedback as well. And if it is good, please subscribe, share it with your friends. Maybe someone can take benefit from this. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.